Okay, so today we are going to talk about how to support open data in large systems, and what we're going to say, it's pretty much aligned to the direction that we saw in the other talks about principles and practice of adaptability in microservices. Right, so let's, okay, so that's us. I think you can see that. So the point is, when we talk about sharing data, what is the drawbacks of just sharing the data sources, right? The first one is like the unexpected overrides. Basically, for example, when you download some data and try to do something, then other people might change this data, and maybe what you did is not it's already not updated, so then you can also have concurrent updates. Then if you don't control this, can be a problem.
You also usually, when you share data but not directly the access, when you have to download the data, usually you find yourself in a poorly aided environment. So you have sometimes your own machine, and oftentimes you have to rework to upload your upload your resources or to update the version of your database of your data.
And finally, when you get the results for yourself, you run that in your machine or personal environment, and then these results are only local. And even if you share the results, other people cannot, let's say, access or re-execute with updated data, right? And I see that happening a lot of times, like when you get the data, run the thing, but then someone else wants to do the same thing, they don't have the access anymore. It's like you get for yourself, and then you keep this in a local environment.
We could also say that this would be somewhat like a violation of open data, because you grab data and you don't provide back, right? So we like to think about a two-way sharing of resources. So we bring also a summary of some scenarios from practice that I think it's somewhat aligned with what we've seen so far here in this event today. So oftentimes we have multiple parts sharing data, and the Open Data Hub is a great example of that. You have multiple parts providing data, multiple parts consuming data, so we oftentimes have to handle this real demand. We also have to consume data in real time. This is a very specific subject. So it's usually we have some live dashboards that evolve even in a small refresh time, but sometimes in a real-time matter. Something's wrong with the slides, but I think it's okay. And we also would like to make the processing available to our colleagues in this collaboration environment. So what we download, what we process locally, we want to provide back. So these are three main drivers, three scenarios that we see happening oftentimes in practice.
And how the right architecture can help on this, right? How we can structure our software components to achieve that, right? So then, let's say we used to be in a world where like we have these big databases and we put all the data we have there, right? And also having application that accumulates the functionality of everything that needs to be done, right? That creates like this single point that any update or any change there affects all the rest, right? So when we have so much different parties participating on the process, that can be very dangerous.
Yeah, because you don't have like a physical, it's hard to say physical in a digital environment, but it's like you don't have a blast radius that contains the entire application. So if something goes wrong in a very specific place, it could like overload the entire system. So instead of doing this monolithic approach that this is usually how it's called, we try to do the microservices approach, where you have like each unit of processing in its own deployment unit. So it runs in its own isolated environment, and it connects in a very lightweight through internet or through lightweight means to communicate, because although they are independently deployed, they are not necessarily independent, completely isolated from each other. They still have to collaborate to achieve a greater goal, the main purpose of the system. So we recommend to follow microservices. But microservices isn't like is not a silver bullet that will completely solve any problem that we have in terms of software architecture.
And it's not like microservices by themselves solves everything. The thing is that how to apply the principles of microservices in a way that you get this adaptability. Like we can see, for example, we have different sources of data. We have different enterprise institutions and business involved. And let's say all of them evolve independently, right? And if we have an architecture that does not favor adaptability, let's say it can be holded, the evolution can be holded by this, right? So what kind of adaptability we're talking about?
Yeah, we deal with adaptability into two major areas in this talk. There are some other features, but in this, for the purpose of this talk, we are talking about extensibility, so extending what you already have to come to with new alternatives. So, for example, if you have a platform that already handles with cars and buses, you want to add solutions for helicopters. So it's very similar to what you already have, but you are extending the same logic. And also, instead of extending what already exists, you want to make it flexible to add completely new things. So if you have a platform that is solves the problem for shipping, for example, and you want to easily integrate a solution for payments, for example. So these are the two main features, the two main standing points inside adaptability that we are talking throughout the rest of this presentation. So extending what already exists, so alternatives, and making it flexible to add completely new things, solution to new problems. Yeah.
And we're going to show now some of the core patterns from the microservices architecture that we believe that are very important to achieve this adaptability. The first one is like we can have different services, which are the balls, right? And accessing a big database that can have data from different domains, right? And as I said, the change in one domain can affect all the others, right? So what we can do instead of this?
So instead of sharing the same database for all the data domains that we have, we recommend to use separate, different databases, each one for one domain. So this is what we call database per service, is the most common name for this pattern. And the idea is that now your database is very specific to one domain, and it's completely managed by one software component, one microservice, so you can have trust to the data that is coming up and going out for external clients, and you don't have to worry so much about explosions that happen in one place affecting the other, so you have more control to every single piece of data in your application.
Okay, so the other issue is like, imagine that we have a service or application that access a service that provides some kind of data. Since we can have other data providers joining, right? When I have, let's say, new providers of the same data, I need to modify my data consumer to access that new service, right? And let's say in a very dynamic environment that can mean several updates in every time that the new data comes in. So what we can do to avoid this?
So instead of having this direct access between the components, we suggest to use an event-driven architecture. So you have a message exchanging infrastructure, a message broker for you to exchange messages. For example, events that happen in one of your microservices that could be interesting, could be important for other microservices to consume that data, to act upon that event. So it's more flexible to add new things because the event is already being published to this infrastructure. So new services can come and simply consume what is already there, and you don't have to change what you used to have to incorporate new things because you already have a lot of trouble to create something new. You don't have to mess with it's already working, so it's a little easier to evolve your application.
And another adaptability we can get from this is when we have some kind of a pipeline, a sequence of processing steps, and these steps are triggered by messages, right? It's really easy, for example, just exchanging the target channels to include new steps in the middle of this, right? They include like parallel steps, new steps, right? So we also get this flexibility in the process, like since one node does not need to know directly which one is the next.
Next.
Okay, so now, I'm going to split the functionality in several services, but now I'm throwing this weight to the clients. Now, instead of maybe consuming a service that gives me everything I want, I need now, since the data is divided, now I need to consume several services. That could not put like all the weight in who is consuming the data. That's not a better way to do it.
Yeah, there is for sure, and it's nice to be here today because we suggest to use an API gateway, so it's basically a single entry point for all your producers or your services, so your clients don't have, your external clients don't have to worry about the internal division, the origins of that data. They only know that comes from this trusted subsystem or entire system. It's interesting to be here because one of the problems that Open Data Hub solves is basically this. Now clients have a single entry point for many, many data providers that are aggregated into a single, easy to use solution. So using this API gateway provides you these benefits, but you don't need to use it only for this purpose, only for like a global solution, a global integration. You can use for a small part of your subsystem. For example, if you want to divide a search algorithms into 3 or 4 different microservices, you can provide a single entry point for the entire region of your system that handles this kind of feature integrated.
And then we can have like, this gateway can select which service to invoke. It can invoke several services and consolidate the data, and can even invoke different kinds of services and execute some business rules or add some functionality, do some analysis to return this. So this way, let's say we don't have to choose between like a lower granularity or a coarse granularity where you have more functionality. We can have both and just compose to get what we want.
And finally?
Okay, and then that's the issue on the data format, right? Of course, the standard is Go, but it's not always easy because sometimes we already have data in different formats. So, for example, in this case, we have these 2 services that communicate like in different formats, right? And maybe my Blue service needs to get the data from 2 of them. And let's say maybe I do want to keep my to provide in my star format because maybe my other clients or internal servers already consume this, but how can I make the life of the Blue service easier?
We can continue to maintain the Blue service as it is, but we can provide a relief for this shape transformation for this format handling to a very specific microservice. So this is what we called an adapter. The blue continues to exist, but now we have someone that is very focused on doing this data transformation for this new format that you still need to support both of them. So these are basically the 4 core principles that we wanted to present to you to improve the adaptability of your microservice system.
This is our context, and we are starting to, we do research on microservices. We are starting to organize a study group on this topic. I can see that many of you might be interested. Maybe to start, we will not have so much space. So if you are interested, please enter in contact for us to talk more about these topics.
Yeah,
Thank you very much.
And these QR codes are for our contacts, so please reach out to us. Thank you.